Now we are going to do the calculation of errors, like we are actually talking about algebra of errors. Okay, so we want to know how much error will be there in the result if there are errors present in individual quantities which are to be added, subtracted, multiplied or divided. That means, suppose we have an equation y is equal to a plus b, okay, and we already know that a has already some individual error, b itself contains some individual error, and we want to know what would be the final error in the answer of y. So for that we are doing the calculation of errors. Okay, so for this again I am going to take examples and I'll explain this concept with some example. Let us consider a is 2 plus minus 0.2 and b is 3 plus minus, or let me take it 4 plus minus 0.3. Okay, this is my individual quantities. Here the standard format which I have used to write the individual values are like this: value plus error. This is how any value is written, value plus error. But why plus minus? Because errors are not direction oriented. Errors are errors. It can be increasing the value of original quantity, or it can also decrease the value of original quantity. So they are not direction dependent, they are independent of direction. They can go either ways, increase or decrease. Alright, so that is our plus and minus, and both are taken accordingly. Now this is the standard format of representing a value if it contains any error, that is a plus minus delta a, which is the original value plus minus whatever error it contains. Now I want to know the final error in the answer, that is what will be the error if two quantities are added up. So the error in the quantity would be addition of individual errors, that is delta a plus delta b. So delta a is 0.2 and delta b is 0.3, so this comes out to be 0.5. So if you will be writing the value of y, y is actually, what is the expression for y? Y is a plus b. What are the original values of a and b? 2 and 4. So y is basically 2 plus 4, which is 6. So y is 6, but I have to write the value in standard format, that is the value plus minus error. So I want it like y plus minus, what is delta y, right? And delta y we have already figured out, which is 0.5. So this would be the calculation of error in case of addition. Now let's try subtraction. So the given equation is y is equal to a minus b. Again in this case we are taking the same values. Let's take these two values only in each of our expressions. So again, in case of finding the error in the final value, the errors are always added up. Errors are never subtracted. So you have to keep that thing in mind. Errors are always to be added up. So delta y would again be delta a plus delta b. So which is 0.2 plus 0.3, which is 0.5. But if I want to write the value of y, y is a minus b. A is 2, b is 4. So 2 minus 4 gives me what? Minus 2. So y is minus 2 plus minus the error, which is 0.5. Got it? So here what the difference is, in addition and in subtraction, errors are always added up while the original value or the main value is calculated according to the given equation. Let's try out the multiplication thing. Y, given equation is y is equal to a times b. Now to find the error in the whole equation, that is I want to know the error in y, what I will be doing is, the format of the answer would be in this way: delta y over y will be equal to delta a over a plus delta b over b. This expression will be used to find the error in the main value. For example, here what is delta y? Delta y is the main error in y, which I don't know. So I have to calculate it out. Y is a times b. A is 2, b is 4. So 4 into 2 is 8. But right now I am writing only 4 into 2, which is equal to delta a upon a. What is delta a? 0.2 over 2 and plus 0.3 over 4. So how do we calculate this stuff? This would be 4 into 0.2, which is 0.8 plus 2 into 0.3. What I am doing is I am taking the LCM and cross multiplication. So 2 into 0.3, which is 0.6 over 2 into 4, right? Here delta y is, so I can cancel out these two terms and I'll get delta y is 0.8 plus 0.6, which is 1.4. So if I need to write the answer of this equation, which is y is equal to a into b, I'll be writing it like y is a into b. A is 2, b is 4. That means 2 into 4 is 8. 8 plus minus, what is the error in multiplication thing? According to this equation, we have got error to be 1.4. So this is 8 plus minus 1.4. So we have done addition, subtraction and multiplication. Now let's move on to division. So our given equation is y is equal to a over b. So the good point is, even in division we use the same equation to find the error in y. So according to this, the same thing, same calculation will go on and will find the value to be delta y will be 1.4, but the final answer for this would be a upon b. What is a here? 2, b is 4, so 2 upon 4, which is 0.5. 1 by 2, 0.5, so 0.5 plus minus 1.4. So errors does not depend on the fact that the error value can be greater than the original value. It can be, okay. So this is how you get the answer. Now I'll supplement these equations with some powers. For example, these are very simple equation. For example, let's take an area of an rectangle. You have been given length and breadth of a rectangle in format. Length is 2 centimeter plus minus 0.2, breadth is 4 centimeter plus minus 0.3. Actually I said it vice versa because length is always supposed to be longer than the breadth, but let's take it this way. So in that case, length into breadth would be in this format. So to find the area, I'll be using just L into B, but to find error in area having corresponding errors in length and breadth, I'll be taking help of this equation and I'll be getting the final error in area, which is delta A over A will be delta L upon L plus delta B upon B, and consequently I'll be getting the same answer. So the equation was simple. My point is, here on calculating the value of area, the equation was simple. It was just length into breadth. What if our equation contains some powers? For example, y is equal to a square times b cube, and we are still maintaining the same values of a and b, 2 plus minus 0.2 and 4 plus minus 0.3. So in this case, what you have to do, what the change in the main calculation equation would be, the powers come as a multiplication factor in the individual quantities. That means this 2 will be here and this 3 will be here. Simple. Even if it is a case of division, let us say this is 4 a raised to power 5 divided by b raised to power 4. So this 5 will be in front of a and this 4 will be in front of the b. That means the powers are multiplied with the error values. This is how we calculate the errors in the corresponding equations.